Number 1, rewrite each of the following expressions in simplest form using positive exponents. So I only want to see positive exponents in these expressions. So let's look at this first one. 2 divided by 4. That gives me 1/2. X to the negative 2. I don't see any x's in the denominator, so we should know that x to the negative 2, the negative means flip it, and I'm left with 1 over x squared. So I have an x squared in the denominator. Y to the negative 2, y to the negative 5th. Well, when I divide, I subtract my exponents. So y to the negative 2 minus negative 5. Be careful here, because you end up getting y to the third. So I have a y to the third left in the numerator. And that's our final answer using only positive exponents. So I go through term by term, deal with the numbers, deal with the x's, deal with the y's, and simplify each of those. This next one, alright, I have this negative 1 exponent, so each of these terms inside the parenthesis need to be raised to that negative 1 exponent. 3 to the negative 1, x cubed to the negative 1, when I have a power to a power, I multiply them, y to the negative 1, over x squared, y to the negative 4th. Well, 3 to the negative 1, a negative exponent means put it in the denominator, take the reciprocal. X to the negative 3 over x squared. Let's deal with that on the side. X to the negative 3 minus 2, because when I divide, I subtract the exponents. That's x to the negative 5th, but I want positive exponents only. So that's 1 over x to the 5th. Times 1 over x to the 5th, that was my x's. Now I need to deal with my y's. Y to the negative 1 divided by y to the negative 4th is y to the negative 1 minus negative 4. Add those together, and I get y to the third. That y to the third is left in the numerator. So my final answer is y to the third over 3x to the 5th. There's only positive exponents there. There's no negative exponents. Number 2, rewrite each expression in the form kx to the n, where k is a real number, so that's our coefficient, and n is an integer. So I want kx to the n. So let's look at this first one. 9x in the numerator, there's not much I can do there. In the denominator, though, everyone needs to be raised to the negative third power. So 2 to the negative third, x squared to the negative third, a power to a power means multiply. Well, what's 2 to the negative third? That negative, since it's already in the denominator, I can take that and move it up to the numerator. I think that's probably the easiest way to deal with that. And the same thing with this one down here. Instead of dividing, as you're going to get the same answer, since I have a negative exponent in the denominator, I can kick it up top. So I have that x sitting there, and I just got x to the 6th from the denominator. 9 times 8 is 72, x to the 7th. So there's really a 1 there. I have 6 x's being multiplied, and another one gives me x to the 7th. So my k is 72, my n is 7. It's in that form. All right, looks like I have a power to the, I have something to the power on the denominator, so I'm going to raise everyone to the 4th power. 2 to the 4th power is 16. X to the 4th power is x to the 4th. 3 over 16, not much I can do with that. X to the 5th divided by x to the 4th, well, when you subtract those, you get x to the 1. It's in that form, a number times x to the n. And finally, 5x to the 5th times negative 3x squared squared. Well, let's deal with that power first. Let's deal with this squared first. What's negative 3 raised to the 2nd? Well, it's going to be 9. X squared to the 2nd, a power to a power, is x to the 4th. 5 times 9 is 45. X to the 5th times x to the 4th. Well, there's 5 x's being multiplied together. There's 4 x's being multiplied together, so I have 9 x's being multiplied together there. And that's in that form, k x to the n. Number 3, explain why x to the 0 equals 1 for all x values that aren't 0. So, why is it true that anything to the 0 power is 1? Well, we know that x to the n times x to the 0, well, when I multiply, I add the exponent, should give me x to the n. The only number, I need something that gives me x to the n. The only number that I can multiply by anything and get that same thing back is 1. So x to the 0 must be 1 because we need x to the n times x to the 0 to give us x to the n. And x to the n times 1 gives us x to the n. So that x to the 0 has to be 1. Your argument should include something along this lines of we need that addition rule to work, so x to the 0 has to be 1. Number 4, Jonah was trying to rewrite expressions using properties of exponents and properties of algebra for non-zero values of x. Of course Jonah is. In each problem, he made a mistake, because it's Jonah. Explain where he made the mistake in each part and provide a correct solution. So let's look at the first one. Jonah said 3x squared to the negative third is 3x to the negative sixth. What did Jonah do wrong there? It looks like Jonah just applied the property there. Everyone needs to get raised to the negative third. So Jonah's answer should really be 3 to the negative third times x to the negative sixth, which is 1 over 3 cubed, which is 27. That should be Jonah's answer, truly. Because it's in parentheses, everyone gets raised to the negative third power. In the next one, 2 over 3x to the negative 1 gave us 6x. Well, let's deal with the numbers at first. 2 divided by 3, well, that's just 2/3. I have x to the negative 1 in the bottom. That negative exponent's going to move it up to the top. So I get 2/3 x. Well, that looks like what Jonah did, but how did he get 6? It looks like Jonah did this. 3x to the negative 1, where there's parentheses around the 3x, because that would bring everyone up to the numerator and give us 2 times 3x, which gave Jonah 6x, which is wrong. Only the x is raised to the negative 1. Only the x, not the entire quantity 3x. So we need to be careful about recognizing what actually is raised to a power and making sure that if it's a parenthesis like over here, everyone inside that quantity gets raised to that power. Or over here, we're just raising the x to the negative 1, not the entire quantity. Number 5, the expression can be written as 2 to the y. Find the value of y and explain how you arrived at your answer. So I somehow need to take this expression and write it as 2 to the y. Now, you could use your calculator, but that takes away all the fun. I see 4 cubed. Well, 4 is really 2 squared. 8 is really 2 cubed. That whole thing is squared over 2 cubed. Now that I have everyone in terms of a base 2, I can apply properties of exponents to help me out here. A power to a power means multiply, so that gives me 2 to the 6 times 2 cubed squared over 2 to the third. I can't divide out those 2 to the thirds because exponents come first in order of operations. Well, I'm multiplying those two together, which means I can add the exponents. I really have 9 2's being multiplied together there. And that's squared. Power to a power means multiply divided by 2 cubed. Do not write 2 to the 6. This is not 2 to the 6, because when I divide quantities with exponents, we subtract the exponents and get 2 to the 15. So this quantity can really be written as 2 to the 15, so y equals 15. In your explanation, you should say something along the lines of, I made everyone have a base of 2 by writing 4 as 2 squared, writing 8 as 2 cubed, and then applied properties of exponents.